Hello everyone, my name is Charles Odari Teachers, and today in the series of calculus, we are going to do limits, but using MATLAB. These are MATLAB software, and welcome. So the first question says, find the limit as x approaches infinity. So the first thing is to have the function, whereby the function is 4 minus 3x squared over the square root of 16x raised to 4 minus 5. So the first thing is to have the function, but the function now is described using symbols. So we should have symbol, which is an x. So the first thing is to have symbol like that, x. Then you can run the cell. So this symbol x, just the representation, like it represents the symbol x that is being there. So after that, after describing the symbol, now we can have the function. The function is equal to, you see that it's 4 minus 3 multiplied by x raised to 4, then over the square root of 16 multiplied by x raised to 4 minus 5. So this is our function. So if you want to visualize our function, that's our function. So you see, our function is just try to rearrange the function, but it's the same. So from this function, we want to find the limits. So you can have the limits. So you can just type limit as f x approaches what? Infinity. You see, infinity. So infinity in MATLAB is written as INF. It means find the limit of x as x approaches infinity. Just like that. So you can run that cell. So the answer is equals to infinity. So how can you prove that this one is correct? Yeah. How can you say that, okay, the function as x approaches infinity, the value is infinity? Because how can you say that? And that in MATLAB is like, in calculus, that's like undefined. The function, as you approach infinity, the function tends to approach negative infinity. So we can be able to visualize that. And to visualize that, we use a function called fplot. So use fplot, you can have a section break. So you use a function fplot to plot the symbolical function that has symbols. So just like that, then you can be able to run. So as it runs, you can see. So here's the function. So you can see as you approach, you see the value is 5. That's the first limit. But if you increase, you see the value is tending to decrease until negative value. So you see the value as the function of x approaches infinity. Infinity is any number like 1,000 in that function, so like 1,000. So this value as it approaches infinity, you see the value approaches negative infinity. So that's how we can do that. The next question. We can add some limit. If you don't know how the fplot does work, in MATLAB we have something called the documentation. This documentation in MATLAB. So you can be able, if you don't know something, maybe you don't know a function that you can use to plot a symbolical function, you go to the documentation. Maybe use maybe you can use Chrome, Google browser engine. Find look for the documentation, read about it, you'll get understandings. So the first thing, see, to get the documentation, you come to the command. Yeah, you can type doc. This, if you use help, it will give you the details about that function. So if you do help, then fplot, fplot. Then you do help, fplot, then enter. So it will give you the detailed structure about the fplot. This one. So you see, it's a function, then fun, then interval. You see, but if you want to get the good detailed documentation, you type doc, then fplot. You open the browser and you'll see a good documentation plus examples, plus some examples of that, how that works and everything. You see, this one has given you the documentation. Let's start from the top. So you see, it has given you the documentation, the function, then this is the documentation with the examples. Then you can see that this is the limit from 0 to 3. So it will plot from 0 to 3. The other one from negative 3 to 0. So the one thing that you can just add on our function, on our things here, on our example here, is to have the limit. So you can say maybe let us have from 0 to maybe 100. How we want to see how the function behaves as the value approaches infinity. As you can see, as the value approaches infinity, it tends to from the value of y, it is like 7,000. So you see, this value is approaching negative infinity, and that is how we can be able to prove both numerically and graphically. The next question says, find the limit as x approaches 0, negative 3 plus the square root of x, 3 plus x over x. So define the function f is equals to negative 3. You have the numerator, so it's negative 3 plus the square root of 3 plus x, then we have over x. So you see, if you plot that one, not plot, but if you visualize it, the function, how it looks like, you can see this is the function. Just try to arrange it. So after that, you can be able to find the limit. Let me have another function so we can be able to find the limit as fx approaches what? 0. Then you can be able to run that cell. So it says it is none. Okay, it is none. Is it true? It's not a number. If you see none, it means it's not a number. Did I type the correct thing? Let me see. Let me check. Negative 3 plus square root of x. Yeah, I typed this the correct thing. So this you can say that is undefined. There's no limit at that point. There's no limit. Okay. Let's head to another question. Because even if you come up with a plot, let me do something like limit as f the f plot. Let me come up with the f plot. Let me have it on another section. Have it on another section. You can say f plot. Because you are we want to see how the values approaches 0. You can be able to approach 0 from the negative side, approach 0 from the positive side. Yeah. So, but you want to approach it from the negative side. So you can have x, but you're approaching from the negative 10, maybe to maybe something like negative. Let's say negative 0.000001, because you don't want to plot in the value of 1, the value of 0, because it gives us undefined. So you can run this section. You see, even there's nothing. You see the function, even it does not appear at this point 0. See, so this is how we can be able to do. So let's see another question. I hope from now you have the understanding, and don't worry, I'll have this script, live script, on my video description. If you head to the video description, you'll find that script. So, and if you have any question, I have the links to my contacts there in the video description. So don't worry, you can ask me any question that you wish to ask. I'm available to answer. So from this, let me find the limit as x as t. It was, I put t, no, it should be x. So I can change here, x. And also, there's some skills to learn. This is called LaTeX. To define this, you use a language called LaTeX. And as an engineering student, you should be able to know LaTeX. That is mandatory. Yeah. Maybe you want to do the good documentation, like the way I define this big thing before I did the practical thing. So here, the thing is to define the function. That's obvious. So it will be like 1, let's say 1 into x minus 2 minus 4 into x squared minus 4. Then you can be able to see the function. So if you want to run this section only, run that section. You see, this is the function. Good. Then we can have another section break. Then you say limit as fx as function f as x approaches 2. Then you can be able to see if you run. Shortcut for running is F5. Yeah, F5. So to prove that, let's see f plot f as x. Not f. So if you have f plot, then you have a function f, but we have in the range between 0 and 2. Let's see, maybe let's say negative 2 and 2. See how the function behaves as it approaches. Okay. Let me let's say just from, let's say 1 to 2. So I want to really visualize that section very well. Yeah. So you can see as it approaches 2. Yeah, as it approaches 2, the value is 0.25. What's 0.25? A quarter. So thank you for watching. In the next session, you're going to do differentiation. And as an engineer, you should be able to have a grid on, so that you can be able to visualize the grids on each section. So Yeah, as an engineer, you should be able to know this. This is mandatory for you, especially when you're doing engineering or any mathematical. MATLAB is the best software that you can be able to use. There's Python, and the next section I'll be showing Python. So I think in this section I'll use MATLAB, in the next section I'll use Python. So you see that having a programming skill will help you a lot, especially when solving problems. You have a different approach in terms of solving a problem. So thank you for watching. Don't forget to hit the subscribe button. We are still growing, and thank you.